Okay, so this video will be about the first fundamental theorem of calculus from chapter 4.4. Okay, so the first fundamental theorem of calculus states that if a function is continuous on the closed interval a to b, and f is an antiderivative of f on the interval a to b, then this statement right here would be true. So the integral from a to b of f of x dx equals f of b minus f of a. So this is really important. This is the function you need to memorize or understand to use this fundamental theorem of calculus. So this is our first example. So to start with this, you would need to find the antiderivative of this function right here. So that would be 1/3 x cubed plus x, and you're going to want to evaluate this at on the interval 1 to 4. Okay, so then you're just going to plug in 4 for x, and then you're going to plug in 1 for x. So start with 1/3, and then plug in 4 cubed plus 4, and then it's f of b minus f of a, so you're going to do subtracting. It's going to be 1/3, then you're going to plug in 1 for every x value. And then this would give you 1/3 times 64 plus 4 minus, and then this would, you have to distribute the negative, so that'd be 1/3 minus 1. Okay, so then this would leave you with 64 over 3 plus 4, which is 12 over 3, trying to get the common denominator, minus, this is 1/3, minus 3 over 3, which is 1, again, common denominator. And this is going to equal, let's see, 72 over 3, which comes out to a good number, which is equal to 24. So that would be how you would do this example. For our second example, we have on the sine of x on the interval from 0 to pi. So again, you want to start with finding the antiderivative of sine, and in this, the antiderivative of sine is negative cosine of x, and you're going to want to evaluate that at from 0 to pi. So again, you're going to just plug in pi for every x, and then plug in 0 for every x. So we have negative cosine of pi minus negative cosine of 0. So we're left with 1 minus negative 1. This turns to positive, which is equal to 2. That was very straightforward. Okay, for our last example, we have a bit of a longer function here. So you're going to find the antiderivative of this function, and finding an antiderivative is very important because if you get the antiderivative wrong, you're going to get the rest of it wrong. So you want to make sure you do that right, or correctly. This should be 3. Alright, okay, so finding the antiderivative of this function, so we're going to have x to the 7th over 7 minus 1/2 x to the 4th plus 5 over 2 x squared minus 3x. and you're going to want this to be evaluated on the interval from 1 to 3. So you're just going to plug in 3 for x, for all of the x values, and then 1 for all of the x values. Just plug it all right in. Okay, so 3 to the 7th over 7 minus 1/2 times 3 to the 4th plus 5 over 2 times 3 squared minus 3 times 3. So that's just plugging in 3. Now, you're going to want to plug in 1. It's going to be very long. So 1 to the 7th over 7 minus 1/2 times 1 to the 4th plus 5/2 times 1 squared minus 3 times 1. Alright? So then, just evaluating this, be 2,187 over 7 minus 81 over 2 plus 45 over 2 minus 9. And then making sure you distribute the negative to each of these. This is gonna end up as 1/7 plus 1/2 plus, or not plus. So minus 5/2 plus 3. It's a minus. Alright, and then just simplifying it even more, you're going to be left with 2,004 over 7. That's the end of this video. Thanks for watching.